Can you hear me now? Ooh, yeah. Okay. So the idea of this talk is that while on my journey to explore the Kotlin language, I found a few things that were interesting or useful. I created a huge list. I counted more than 50 items. I think I did about half because then I ran out of time. So this is Kotlin Mind Blowers episode 1. You'll have to wait the next Kotlin night to see the rest, I guess. I don't know. But still, yeah. There's a few animations, but not too many, because again, it's run out of time. And also, animating code is just worst. So, anyway, you might have seen a lot of things, but do you know the Carrefour logo? Yeah, the Carrefour logo. I should have added it to slides. Anyway, it's a C. And no one sees that, but once you see it, then you cannot unsee it, and it's trivial after that, right? So this is the same. A lot of things are trivial, but then once you see them, you're like, oh. And feel free to oh every time, okay? Yeah. You want to try? Great. Okay. Why did I add this line? I don't know. Okay, let's start with something simple. Mind-blowing fact number 1. Kotlin is also a ketchup in Poland. Yes, I tried it, and yes, it surprisingly tastes like every other ketchup. So, I have to say though, they do have a really good multi-platform support, so can't say anything about that, honestly. All right. Now, seriously, let's start with the deprecated annotation, if you've ever used that. So it's something that comes from Java. Everybody knows that. Imagine you have, deprecated function. You put the deprecated on top of it, because then you decide to create a new function that actually wraps the elements in a type-safe way, whatever. This is just an example. When you use the old one, the only thing that happens is that you get like a warning saying, hey, this is deprecated. But Kotlin can do a lot better. So Kotlin has something that is called levels of deprecation. The default is a warning level, which is what you get here. Then there's the error level, which means now whenever you try to use a function, your code will not compile until you not use it. And then there's the hidden one, which is even better. It essentially completely hides from the scope that function so that not only you cannot compile, you can even find it. Like if you try to autocomplete or even import it manually, it will not work, which is amazing. Oh, okay. Good. Very spontaneous. But it's not over. This is just a piece of it. The other thing is the replacement patterns. You can actually specify, you can specify both, by the way, the level and the replacement. You can specify a replacement for your function. So notice one thing. The arguments in the deprecated functions are inverted. So it's age, name, and in the new function is name, age. Not only that, but it's wrapped inside a different object, right? So you can specify like text, literally source code, inside this string. And what happens is that now you're going to get a warning as usual, but with like a quick fix. And when you click on it, you're going to see this. So not only you can quick fix it there, you can quick fix it everywhere. Like this. And that is actually a super nice way of doing like easy refactorings across your projects, because it just happens to be there. It's super useful. So, and like imagine if you create a library and you add this, it makes it so much more convenient for your users to just migrate to the new things. So amazing. In a way, it kind of changes the way you feel about deprecating stuff, because now it's actually nice. Like before, it was just a pain to go and dig what you had to do, lots of documentation. Now it's just integrated, so that's great. And in fact, we're happy. It just replaces directly. Okay, another thing is type aliases. So type aliases are easy. You just alias another class, and that's cool. There's a few usages, though, that are really nice, and people generally don't realize how powerful they can be. So not only you can create as many as you want, even private, just for readability's sake. So you just add them to describe better what your types are, and that's one. I also use them a lot when prototyping, because then you bind your types, which are generally, they change very fast when you're prototyping, to one place. And so if you have to refactor something, you just change the one place, and it changes all the types at once, which is super nice. Also, if you ever have the like multiple generics that you have to specify every time, as an example, subject in RxJava, if you want to use the base class, it has the double generic. I don't know why. I never encountered a case in which the two generics get different, but still. And so if you want to keep it as a base interface, you have to specify the same thing over and over. With a simple type alias, you don't have to anymore. So that's super cool. And we can even combine the two. So imagine you have a boring class. And you just create an instance and call a method on it. Fine. Somehow, you find that your users are not very excited about using this class. And so you decide to do something else. You rename it to exciting class. But now, of course, if you do that, what happens is that the code won't compile anymore. Like, of course, if it's in your project, you can refactor, sure. But if it's, again, a library, there's a problem now. And the point is, you haven't just created a new class. You have literally replaced the same class. So there's no other class to go through. So the trick with the deprecated annotation would not work anymore unless you use a type alias. So you can create a type alias with the old name, point it to the new class, and then deprecate it. And so what happens there is that you're finally now going to get the ability to specify a replacement. And when you do that, it will just replace it as we've seen before, which is also amazing. Oh, you're learning. Nice. What is the next one? Yes, the next one, I have no idea. Yes, right. So, you can specify top-level functions in packages. And when you use them, you import them, right? Say that you do this. You're in different package, and you import top-level function. What did you import? You actually imported all of them. And this is both powerful and a limitation in the sense that there's no way to not import some of them. Although if you have something in your scope that is closer, it will win over that, but still. And this is also true for documentation. If you ever try to target a specific overload, you won't be able to. You'll only be able to target the very first, essentially. So also kind of plan your positioning accordingly. Like if there's one main method, it should be the first because your documentation will just go there. So, right, something else. Packages. So imagine you define a color int data class just to typify your integers. And then you decide to add an annotation to it. As an example, color int from the Android support library. This is fine because we defined everything here. There's no clash. The compiler is smart enough to understand the difference between the two types. But if you try to use it in a different package and you try to import both, of course, the compiler will complain, right? What can you do? Well, you can have a name import. So you can just give a different name to the thing and use it differently. It's almost like an import level type alias, pretty much, that allows you to disambiguate between different things. And the super weird and nice thing is that you can import the same type multiple times with different names. Why not? I mean, in a way, like you could be at a state where your types are not ready yet, which is fine, but you can still have a placeholder for different things. So, and then you can replace it later when you actually have something concrete. Why not? Or you can just mess around with your colleagues. That's amazing. Like, you can, I don't know, import string as something that is not a string. That would be amazing. Anyway, yes. So something else which is super nice. So imagine you have a functional style thing like this one, right? So this is just an example. Of course, it's bullshit, but we have a list of strings. For each string, we make it a character array. And then if it's a digit, we return from the entire function an empty character array. No, sorry, from the mapping function. Or we just keep on mapping and make the character uppercase, whatever. The point is, you say return map. Which map are we talking about? Not only it's ambiguous, like, of course, like, it is the closer one. So that's it. But the point is, it's really not very readable. Is there a way to make it better? Actually, there is. You can have named lambdas. So every block, pretty much, you can give it a name in the form name at, and then you can call it. And you can do all the, you know, return, blah, 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 break, blah, blah, blah. You can name them. And finally, you can give it like real names, which is super nice. Next. So imagine you have this function where you've probably done this 1,000 million times, especially in Java. So you have something, and you say, if it's one thing, then I want to do something with it. Otherwise, just return null. I don't want to continue. There is a super straightforward way to do this, which once you start using, you cannot stop using. And it's the as question mark operator, which is similar to the one that essentially casts something, except this is safe. It either can cast the thing to the type, and then it does, or it returns null, which is amazing. And so you're saying, if this is a string, then give me the length, otherwise just return null. And yes. Next. Do you know that asterisk there? It's called the spread operator. The idea is that when you have variable arguments, vargs, things, the only way you can pass an array as arguments is by spreading it over the thing. Otherwise, it will be one element of the var args, essentially. The point is, okay, now imagine you have a more complex usage where you don't have one array, you have two arrays and two single strings, okay? How do you pass everything to that function? Do you have to create an intermediate array and then put all the things and then pass it? Well, it turns out you don't have to. You can mix and match a spread operator inside the thing, and it's so cool. The first time I saw it, I was like, no, it must be a compiler error. It can't be. But it's true. And if you look into the bytecode, it's also super interesting. They create a spread builder, which is this class that pretty much does the intermediate steps for you. And I think they also optimize it away or something, so it's better than doing it by hand. Then, so we have a function, very descriptive. Have you ever used default arguments for a function? Right. So one thing that people don't realize sometimes is that default arguments don't have to be just values. They can be any expression. Not only that, they can also reference other arguments that you've given in the function. So in this case, you're saying, take the first argument, take the length, and that is a reference to the same argument. And you can even do way more than that you probably shouldn't, but you can. You definitely can. So, like, again, this is an expression in the sense that there's even the Elvis operator. So, like, you can really do programs inside of that. So, don't. Who has used sequences? So many. Good. So what is the difference between an iterable and a sequence, given that they are the same interface? Like, they literally have one method that says, give me an iterator. That's it. The difference is semantical. So an iterable is meant to be used as you normally use collections. So, like, you create a copy every time, pretty much. Sequences, on the other side, are lazy by default. And so what happens is that being lazy, they become this, if you ever use RxJava, you'll understand, it's like a pool approach where you only emit an item when it's requested. So you can have an infinite sequence, and that will not create an infinite list. It will just stay there like a generator and wait until you pull the next element and then do something. The interesting side effect of this is that when you iterate over them, And so we have these two methods, iterate and sequentiate. Why not? So you have a list, A, B, B, C, C, C. And what we want to do is, for every element, we print the element, and then we map the entire thing by extracting the length of the strings, and then we print the length, okay? So, trivia. What is the first one gonna print? The iterate. If, you know, like, yes, good. And the second one? So as you see, the iterable one goes through the entire step of the chain before proceeding to the next one, because it literally creates a copy every time. And so you have all the strings iterated, and then all of them are mapped and then printed. The sequence is exactly the opposite. Every time the for each requests an element, let's say, it goes through the entire chain one by one. And so you have A, 1, okay, B, 2, okay, etc., etc. So it's a huge difference. Not only that, in the iterable version, if you just say iterable.map, you will create a new collection, okay? In the sequence, if you just say sequence.map, you won't create anything. You will create another sequence that is lazy. So if you expect like a side effect of that happening, it won't happen until you call for each or any of the, how do they call them? The, like terminal operations. They're the ones that actually like make it concrete, like they actually take something out of the entire thing. So then something about theory. You know Java, void. Is void a type? No, it's not. Good. It's a keyword, although it looks like a primitive type, like it could be as well. But Kotlin has a different approach. So the equivalent of void in Kotlin is unit. And what is unit? And why unit? Because in type theory, unit type is a type that allows only one value. So by definition, this is the best singleton ever. It only has one value, which also, as part of the definition, does not contain any information. So it's not like a mutable singleton or any bullshit like that. It's like, you know, just identifying something. In fact, unit is single instance. And in Kotlin, since pretty much everything returns an expression, is an expression and returns an expression, even functions return unit. Literally, you can write this, and this is fine. This is perfectly valid code. In fact, sometimes I do it just for fun when you create the empty methods. You do this, and you know, you're just one-lining stuff. And so what that means is that you can use expression syntax for things that return nothing. And so you can do this. Print line doesn't return, but you can say equals because it returns unit, technically. And so you can one-line stuff that normally is not one-lineable, which is interesting. And it even works for Java, despite the fact that in Java, it actually does not return anything, but the compiler does it for you behind the scenes, essentially. So, and that was one side. The other side in Java is void with a capital V, right? Which is the equivalent, classified, all of that. Is this a type? Good. It's a type that cannot be instantiated. Turns out we have something exactly the same in Kotlin, and it's nothing. It's true. Which, in type theory, the zero type is a type that has no values. It's sometimes called empty type and sometimes bottom type, because it sits at the bottom of the entire type chain. And so, yes, it's a type that cannot be instantiated, and this is the key to the whole working of nothing. So, nothing can be used in many ways. For example, there's a slight difference in the way that Java uses void and Kotlin uses nothing. Because in Java, there's no nullability per se. Like, everything is nullable. And so when you say you return void, it means you return null. It's the only thing you can ever return. And so in that sense, it's more equivalent to nothing, question mark, so nullable nothing. And if you think about it, that's one type. That's literally only ever null. It can never be anything else than null, because you cannot instantiate it. You cannot get an instance of it from anywhere. So it's a perfect representation of I'm always going to be null. But you can use nothing in other ways. So imagine you have a function that does an infinite loop, which is not necessarily bad. It can be like an event loop. It can be anything. And then you have a naive function that expects that function to return, because it has no idea that it will never return, and just assumes things will work out. They won't. What we can do is explicitly specify that that function returns nothing, because it will never return anything, and suddenly we're going to get a compile time warning that says this code will never be executed. You can use it in an even better way, and I love this. So imagine you have a function, like a very complex type, and you don't want to specify that right now because you're in the middle of developing or something. You can do this. Why you can do this? Because to do returns nothing. And so the compiler just knows that it doesn't matter what type you're expecting. It will not be wrong because there won't be a type. And so this is why it works. And it's like, what? Amazing. Okay, we are running out of time. So data class, okay? Simple, Pojo, no, Kojo, whatever. You want to parse this. You could write this abomination if you wanted to extract, like from, imagine like a JSON structure, all the pieces you want. Or you could do it a little bit better. You could do it like this. At least you avoid the indentation. So for every piece, you say, if it's not what I want, return nothing, null, and blah, 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 and keep on going. Or you can use the Elvis operator, which is like my favorite operator. And you can do this. And so suddenly you're starting to inline the fact that it's either what you want or you just return from the entire thing. But then at this point, why stop? You can do even this. And it's amazing. So this is a pattern that I started using a lot in production, and it just makes the code so readable unless you use something more extreme than that. But like just using the return is fine. And so return is an expression. It returns something. It actually returns nothing. Surprise. And same is like break. Same is, I think, continue, perhaps? Yeah, anyway. So reasons why you can do that. And you can even do more things. After the Elvis operator, you can have like a run function, the one without the receiver. And you can specify multiple lines inside that lambda. So you can have something like, do something, or if it's null, execute this block, which is great. By the way, do you know why it's called the Elvis operator? Yeah. Okay. Last one, I think, if I'm not mistaken. Did you know that Kotlin supports operator overloading? Do you know all of them? Because some of them are surprising. So these like simple ones, like unary operators, you can do cool stuff with it. Like it's nice when you need commodity operators in DSLs. Don't abuse it, please, because then you have this one, which is like the range to operator allows you to do really interesting tricks, for example, because it's like nice to concatenate things one after the other. Then we have like assignments, which also nice. And the interesting stuff is that this doesn't mean you are mutating the thing necessarily. This can return something. So you can do this on an immutable collection and return a new collection, for example. Crazy. Super nice also the like array syntax access. So you can both get and set stuff. And you can use it however you want. Like it doesn't have to be about collections at all. It can be about tokens or whatever you can imagine. And you can have multiple overloads that take multiple number of them. Then, and this is something that I rarely see used, but it's so convenient, if you implement the comparable interface, of course, all of these need the operator keyword before when you do the function, but you can actually use stuff like this. You can say equals more or less and stuff. It's crazy. It's super good. And then another one that I don't see often, but it's super nice, it's in. So if you have the contains overload, you can say, is this in that? So it could be a date, like a day in a date, for example, or something like, it's super nice. You can use it with ranges, etc. And then invoking. So you can make anything invocable. Like, you can take anything you want and make it so that you can call something on it, or at least it looks like that, and then you decide what to do. And the most amazing thing about all of this is that you don't have to implement them in a class. These can be extensions. So you can add an invoke extension over a type that you don't own, and suddenly you'll be able to invoke stuff over it. It's crazy. Good. And there's one more, actually. Have you ever seen the by delegation, property delegation, which is super, super powerful? I wanted to add more, but I couldn't. Oh, no, there's a broken slide. Oh, whatever. These three operators are the ones that make it possible. And again, I myself realized it the other day. You can use these as extensions. You can take something and make it a delegate, and then suddenly you can say, by a type that you don't own, and it does stuff. It's like, what? Wow, amazing. Yeah, so don't look at this slide. Next, do you recognize this? Ah, come on, don't spoil it. Yes. Oh, you can see that I started from the end of the deck to do the animations. Do you know who took that picture? It's our favorite person that, by the way, spoke here at this event the previous time. So Jole, also known as other names, but Jole is the most common one. Kotlin Tools team lead, he took that picture, and even better, he came up with the name Kotlin. Did you know that? Oh, good. Thank you. You can find the slides in the future at that address. And this is my Twitter, follow me and stuff, and that's it. Thank you.
Thank you, Eugenio. We have a short round of questions, please.
Only 7.
Which is your favorite mind blower?
That's the hardest question. I don't know. Like, my latest was understanding you can add extensions to the by, for example. And I'm in love with that right now, for example. I don't know. You can add extensions over functional signatures. So you can have a method reference, like, you know, and then add an extension over that. And so you can start doing things that are just insane, for example, or you can add extensions over a lambda. So, you know, things like that. I love that kind of stuff. So, yeah.
Next question. Yes.
Thanks, Eugenio, for your talk. My question is, now, if you have a list, you can set and item, and you set it. You use these square operators. For example, in bundle, you have set boolean, set string,
sorry?
bundle, like Android bundle. Yeah. You have set boolean, set string, and so on. Can you have like one operator, this square bracket operator, to set multiple things?
I'm going to disappoint you. So, if you like type safety, no. Because the problem with this is that you can only have, oh, actually, that's not entirely true. So the problem is that you risk creating a signature clash. So if it's something generic, for example, you can only have one of them at a time, because of type erasure, they're all objects. But if they are different types, like if it's int, string, blah, blah, then yes. I think you can do that for bundle, actually.
I tried and... Okay, and I will try again.
What happened?
That it only... you cannot have multiple. Like the square bracket for string, square bracket for int. It cannot do. We can try it out. Thanks.
Yes. Come to me later.
Thank you. Thank you, Eugenio.